Buenos dias. ¿Cómo estás? Me llamo Joe Clarke. Bienvenidos a Flowin with Wireshark, hacks and tricks to rule your network. It's almost exhausted all the Spanish I have. I'm glad you're here in the Cisco U theater today. Before we get started, maybe a little bit more Spanish. ¿Quién aquí es network engineer? Who's a network engineer? All right, we got some network engineers. So you know that as a network engineer, you've heard someone come to you and said, yeah, I'm seeing this really weird issue with the network. I go to connect to something and my neighbor, the person sitting next to me, they can connect, I can't connect. And you're sitting there going, okay. Whoop. It is on. Well, we'll just do it manually. Show me the packet capture, it didn't happen. Prove it to me that you're seeing this weird thing in the network. And that's what we're going to go through today. We're going to show you things about our favorite packet capture tool. ¿Quién usa Wireshark already? Who's using Wireshark? Perfecto. A lot of hands went up. So we're going to look at things. You probably already know quite a bit about the tool, but we're going to look at some things that perhaps you don't know. Perhaps some features about Wireshark you haven't been using. Specifically, see if it works now. Ah, great. Specifically, we're going to look at this feature that was somewhat relatively new, using packet diagrams to explain or be able to visualize more about the individual packets and how the fields in the packets break down. We'll look at the remote capture utility, which can be very useful in a containerized world when we're trying to troubleshoot container-based applications. Almost everything these days is encrypted, and we still need to be able to troubleshoot. We still need to be able to look at those packets and get an idea of what our application is doing beyond the encryption. So we'll take a look at an example there. And because we had to trim the timing down, I have some extra credit in here, and I'm going to give you access to these slides, so you'll be able to look at some of this information later on as well. If you're not already using Wireshark, here's the QR code. You can scan that. That'll take you over to wireshark.org. You'll be able to download it, and you'll be able to do everything we're doing here. The latest release, 4.2, just came out, so there's a fairly new version of Wireshark, more dissectors, more ability to look at the traffic that's flowing through your network, and more ease of use features. Some of the things we go through today, though, they'll work on slightly older versions of Wireshark as well. I don't like to do a lot of slides, so this will almost be my last slide. What I want to do now is take you into a live demo of all of these things. Sound good? ¿Está bien eso? Excellent. So here's Wireshark. I'll make it a little bit bigger. Hopefully you can see that. So I'm just going to start a live packet capture on the network. And you can see that it's already, even with my laptop here, even with me not doing anything, there's a lot of apps running, a lot of background noise, a lot of things happening. If I click on one of these packets here, say I click on just this TCP, what did I do? I'll get TLS. Over here in this window, in this frame, it by default shows me the packet bytes. Shows me this every byte of this packet broken out. And if there's any way to translate that into some ASCII character, it will. That's not terribly useful. You're all here in the Cisco U theater. Cisco U is all about education. I work with the Internet Engineering Task Force, the IETF, a group of engineers who helps to build the standards that run the internet. And as part of that, they put together these documents called RFCs, requests for comments. These documents are the things that describe the protocols that we're using, from the IP layer, from the network layer, on up into the application layer. So they'll have these packet diagrams in these RFCs that show you these are the fields in like an IP header, or these are the fields in a TCP header. And oftentimes, as we're trying to educate new network engineers who come into the fold, we want them to appreciate what it looks like, what a packet, what the fields in the packet actually look like, because that can help them solidify their understanding of networking. This type of view doesn't necessarily help them understand that much. And so a few releases back in Wireshark, they added the ability to add a little bit more educational flair to this. If you go to Wireshark, or essentially this is for the Mac, it works on all versions, but if you go into preferences, however you get there, layout, you'll see that you can adjust the various panes that you see in Wireshark, the various sub-windows that you see here. And over here in pane 3, this is pane number 3, you can choose what you want to see. You can see a packet list, that's what we have in pane 1. You can see the packet details, that's what's in 2, and packet bytes is the default in 3. There's another option though, packet diagram. Somewhat new, as I said. If I select this and I click OK, the bytes are replaced with this RFC-like, this standard-like depiction of every one of the fields in the packet from, in this case, the Ethernet layer 2 on up. So if you were like, remind me again, how large is an Ethernet address? How large is the Ethernet address in the packet? You can look at this. You can see the width, the number of bytes that each particular field has, and you can see the fields in order they're in the packet. From layer 2, all of the layers that are supported by Wireshark, all of the protocols all the way up in that particular packet. And this gives you a great educational look at how this network works. As a junior engineer, this is the way I want to understand networking. And even as a senior engineer, do you remember how long an LLDP specific TLV field is? Like the other day, I was trying to look something up and say, how long? What should I expect this particular field length to be? Wireshark makes that so easy for you to get out with this packet diagram that you can also, if you right click on this, you can say copy as raster image, and I can come over here to my preview application. I can spell preview, there it is. And this is just an image now that I can print out. So I can have educational, I can add this to slides, I can add this to documentation that I may be giving out to my engineers that help them understand how the packets are put together and all the fields in there. So Wireshark can be that, not just that troubleshooting tool, it can be that educational tool that you have for your network engineers, for yourselves. And of course, any one of these fields are independently clickable. So if I say I want to look at the TCP options, I can click on that field. It'll expand the details window, the packet kind of tree structure here, and take you right to that particular field in the packet details. So you can look at that, the specific value of the TCP options field in more detail. So that's the packet diagram feature, something you may not have seen, because if you've been using Wireshark as long as I have, I was using it back when it was called Ethereal, the original open source packet cab. Was like, this is the greatest thing ever. I never even knew this thing existed. I was always using those bytes displays. Wasn't terribly helpful, but this gives me a lot more perspective, a lot more clarity of how those packets are put together. Make sense? The next thing I want to do, and I'm going to go back to the slides a little bit to introduce this. So this day and age, this day and age, a lot of applications that we're deploying end up becoming containerized. There we go. End up becoming containerized. That is, we deploy an application on a host, and we deploy maybe multiple applications on these hosts, and they're all in their separate little Docker container spaces. And there's a separate networking layer here. So we have on this, let's say this box here represents one Linux host. We have multiple applications here running as containers, and we have various virtual switches within that host where they connect to and they expose their networking services to. Then we have clients out here on in the internet, external, trying to access these applications, oftentimes through a reverse proxy. Oftentimes, you're not accessing the application directly on the port it exposes. You go through a service like Nginx or Apache, And it provides things like SSL or TLS certificates, and then proxies that request through this virtual switch back to the application itself. If you're trying to troubleshoot this, and you're trying to troubleshoot, say, why this user can't access the application or is getting some weird results from the application, by default, when you're doing that, if you're sniffing, if your packet capture is out here, you're just getting the TLS encrypted traffic. Here's an example. So over here in Firefox, I've got an instance of NetBox. This is the NetBox single source of truth that we run at the IETF. So I told you I work with them. I help them with their network. This is set up exactly like that slide depicted. This is running as a container on some host out on the internet. And I'm a client here. This is running actually in Dallas, Fort Worth, Texas. And I'm a client out here in Cancun, Mexico. If I'm having a problem or if I'm seeing some weirdness and I just try to sniff on the HTTP interaction my client is having with this container, let's see what we see. So I have my filter saved just so I can weed through all of the interesting parts. There's that. And I'm going to then reload this Firefox. So there it reloaded. Let's say I saw something weird, something I didn't expect. I come back over here and I should have, where am I capturing? Capturing on that. That should be the right address, I think. Let's take it out. Let's take the filter. Maybe wrong address. So I'm just seeing TLS. I'm seeing encrypted packets. It doesn't really help me. It doesn't really get me to what the problem I might be trying to solve is. However, there is a feature in Wireshark independent of being able to decrypt this. We'll look at decrypting this traffic in a second. But there is a feature in Wireshark where I can filter specifically on that virtual switch from where I am. In the past, what I had to do this is I'd have to get on this host. I might have to run TCP dump or T-Shark, export that packet capture, then bring it over to my laptop, open it up there and look at it in Wireshark. Not the greatest. With this feature called SSH, remote SSH packet capture, I can streamline all of that. I can make that a lot easier. So if I come here to Wireshark, stop this capture, scroll down, you'll find at the bottom here of your various network interfaces, and my Mac has a lot of them. There's a few of these that are remote packet capture interfaces. There's Cisco Dump. Cisco Dump is nice. Cisco Dump works with the packet capture features on a Cisco device, so you can live capture traffic from a Cisco device and show that in Wireshark. I didn't have a Cisco device set up for this, so I was using something that's a bit more generic or a bit more general, and that is this SSH dump feature. SSH dump allows Wireshark to SSH to a remote host and set up a packet capture on that remote host and stream the packets back so that I can visualize them here in Wireshark. And that's exactly what I'm going to do. First thing I need to make sure of is that I've configured this correctly. So I'm going to point it to the host that the container is running on. In this case, the container runs on a host called docker.noc.ietf.org. It's SSH. It's using the standard SSH port, so that's 22. I set up my authentication. I'm going to use my user ID, and I point to my private key. I recommend you use private key infrastructure here versus putting in an SSH password, but if you needed to use a password, you could do that as well. And then I'm going to specify the interface on which I want to capture on the remote host. In this case, because the container networking all uses in the back end, it's all using the loopback interface. That means the containers expose their ports on the loopback of the host, and the reverse proxy, the Nginx, I think it's Nginx on this host, the Nginx also can obviously talk to its own loopback interface, and that's how it proxies those requests. So I'm going to do a remote packet capture on docker.noc.ietf.org, the host that's running my container, the host that's running Netbox. I'm going to log in as me. I'm going to capture on the loopback interface. The rest of this is all default. This will be the default settings. I don't have to touch that. This is a Linux host, so I know that TCP dump will be there. If there was another packet capture utility that you wanted to use, you could specify that here, but I'm leaving everything to default. I use sudo, or I leave it as sudo here, because TCP dump will need to run as root in order to put the interface loopback in promiscuous mode and get all the traffic I want. So I'm going to do it this way. Save these settings, and then I'll go ahead and start this packet capture. So far, no traffic. So let's hope get this out of the way. I'll go back over here. Okay, I'm already seeing some activity from the browser. I'll reload this page again. Reloaded. Come back here, and now look what I see. I see things that look nice. I see some HTTP in there. That's nice. So what happens if I go ahead and follow that HTTP as an HTTP stream? Now I see the actual HTML. I see the images being loaded. I see the data that's coming back from my Netbox machine unencrypted, because what I have in the back end, what the reverse proxy is doing, is it's doing everything unencrypted in the back end to Netbox, and it's exposing TLS on the front end to my client. So now when my client, say Joe out here in Cancun, says, I'm having a problem accessing Netbox back in Dallas, I can troubleshoot, I can look at that live session, that live traffic session of that user, and I can see what they see. I can see the packet capture. It did happen. I have the evidence, and I can see it in its unencrypted form. I get all of that data. I get everything that they're seeing. And that's how you can do these things, where you have that kind of additional hop that you have to go through in order to get to the traffic that you're actually interested in. You can do that with the remote packet capture options. We just looked at the SSH remote packet capture, but as I mentioned, there are others. There are others you can play with. They come built in with Wireshark. Talked about the Cisco dump. That's talking directly to a Cisco device. Then there's a UDP dump where you can get just streaming UDP datagrams. This is interesting from some other vendors. They have I know one, MikroTik off the top of my head, that will stream UDP packets that you can plug into that and have Wireshark look at that. And then if you have the ability to do, you have a specific key, a specific hardware device, you can do Wi-Fi dump as well. Again, all built into Wireshark and can be extremely helpful in some situations. The last feature, kind of interesting bit of Wireshark I wanted to look at, is another way to look at or to get at unencrypted TLS traffic. A few years ago, that same group, the IETF, their leadership made a mandate that all new protocols being standardized on the internet must be encrypted. You cannot standardize. They will not ratify or approve a standard that doesn't include a standard protocol that doesn't include encryption. Can't do it. It's for purposes of obviously security, but more importantly, privacy. After the whole Edward Snowden thing, privacy became a key issue at the IETF. And they made sure that all traffic is encrypted. You're not going to see. So the more and more we start to look at the traffic that's on the internet, the more and more it's encrypted. That's why you're seeing a lot of these security solutions. They're doing crypto analysis. They're being able to do some man-in-the-middle type decryption of packets, because that's what you need in order to be able to provide observability and in order to be able to do troubleshooting. And Wireshark has the ability, if you can see the entire crypto negotiation, it has the ability to decrypt some protocols. In particular, it can decrypt TLS 1.2. If it can see the entire setup, the entire handshake of the certificate exchange between the client and the server, then you can look at that traffic unencrypted. So you can't just get someone's like in the middle of their exchange stream and have Wireshark magically decrypt that. You have to be able to see all of the information and save out all of that key data. Most modern web browsers, and I say Firefox, Chrome, Safari, I think Edge because it's based on Chromium, have this ability to dump that key information. And Wireshark knows about this. And there is a feature built in since 3.4 that if you go up here to Tools and TLS Keylogger, you can specify where you want all of that key information to be written. And then you can say, what browser do you want to use? And click the launch button with the browser initially being closed. And Wireshark will start the browser with the right environment set so that the browser knows to dump all of the key information into this file. Then Wireshark will use that key information, and I'll show you what that looks like. It'll use that key information to decrypt those packets that you're looking at, the TLS packets that the browser is retrieving from the web server. So this window is probably going to be a bit hard to read. I will attempt to. Once. Well, it's not terrible. I'm trying to remember how I edit session. That's it. Colors. There we go. That's a little bit better, but could probably make it even easier to read. And now I'm going to look at this SSL keylog file. Oh, now inverted. But you can see this is what that key data looks like. It's not terribly useful in and of itself, but this is what Wireshark needs to be able to do that decryption, that live decryption. So let's take a look at an example of how this looks, how this would work in your workflow. I have a web page set up at my server at home, this web page. Very simple, but you get the gist. If without doing any of this, without actually relaunching my browser, so I'll make sure that it's not launched that way. I'll quit it. I'll start Firefox again. I'll go to this web page. Okay, that should be good. I'll start a new packet capture. On the right interface this time. There we go. And I will put in my filter for home. My home IP address shouldn't have changed. And I'll reload this page. And somehow, I don't know if where I'm going out on. 192. He's got an Ethernet card plugged in here. That would explain why I wasn't getting anything that I expected. Now I should be on the wireless. Let's try this again. There we go. So this is my connection out to my home. You can see there's the key negotiation, the certificate negotiation. I see up top SNI right here. I see SNI www.marcuscom.com. So that's the server I'm going to. Okay. But all of the rest of the data is all encrypted. This is the default. This is what I would see. I don't get to see, here's application data. But if I were to go and follow this stream as data, it's useless to me. It's garbage. I'm not seeing the clear text. I can't troubleshoot what might be the underlying problem. Unless I'm looking for latency issues between the client and the server, just seeing the TLS doesn't help me. I need to see the data. I need to see the clear text data behind that. And that's where this live decryption comes into play. So now if I go back to, if I quit Wireshark, so I need to start a clean session. I go to Tools, TLS Keylogger. I've set everything up the way I want. I'm going to click Launch. It's going to invoke a new session of Wireshark. And now I'm going to go back to that address. But just to clean things up a little bit more, I'm going to stop, put back my filter, and start it up again on my wireless interface. Now when I reload this, that's looking a little bit better. I still see the negotiation. I'm still getting all of the packets that I should be getting. So I still see the certificate www.marcuscom.com, but now I'm seeing real HTTP in there. So if I click on this get Cisco U.html, the page that I loaded, I can follow that as an HTTP stream, and now I get the full data. In this case, it was cached. If I come back and I do a shift reload on that page, that should avoid the cache. And now I can see everything coming back. If I follow this as an HTTP stream, I see, whoop, that's not that stream. I'll start it again just to clean things up. Do a shift reload again. Now I see everything. I see the image load. That's the image, the Cisco U image there that I had. And then up here, I get the, that's the icon. That's the icon again. And there should be a get Cisco U.html. Follow, right click correctly. Follow HTTP stream. Now I get all of the HTML that was in there. I get the HTML, I see the image load, I can see the image loading. I have all of that data, everything that the user did, everything that the user browser saw, I see in its unencrypted form. And that's how you can use that. Again, you have to see the whole session. You have to see that whole TLS negotiation, and you have to be saving off that key data from the browser. I mentioned Chrome, Firefox does it. Command line tools like curl also support this. So you can even have your automation tools dumping that key data so that you can look at those transactions, you can look at them in an unencrypted form. So with that, we're just about at the time. I want to take us back to the slides real quick. Close this out. All of these slides, all of the slides that I offer here go through each one of those scenarios that I did, but do it just in a canned way. Thankfully, once I realized that the Ethernet cable was plugged in, the demo gods were favorable. We got to see all of this live, but you can go here, scan this QR code. You'll be dumped into a Get repository. You'll see slides for this session. This was Cisco U 1013. You can get the slides that I went through, all of the scenarios that I went through, including a few extras that we didn't have time for. So I'm grateful you are here. Thank you very much. Muchas gracias for attending. But before you go, someone has under their chair this little tchotchke, this little icon here. If you have it under your chair, you have the option of winning either one of these bottles. Congratulations. You can either take the bottle, or we have a Cisco U pickleball set. Your choice. Bottle? Well, okay. And I'll take that. Thank you very much. Enjoy the rest of the show. Enjoy La Fiesta tonight. And